In this section, we're going to look at something a little bit different, although still using that same idea of bell curves, and talk about something called sampling distributions. So let's go through some definitions. A sampling distribution is the probability distribution of a sample statistic that is formed when random samples of size n are repeatedly taken from a population. If the sample statistic is the sample mean, then the distribution is the sampling distribution of sample means. And every sample statistic has a sampling distribution. So this definition, I think, is extremely confusing, what they're trying to say. So what they're trying to say is you have a population, right? So let's say our population is students at the Mount, right? And we have a survey we're going to put out, whatever it is. So we're asking them a question. Maybe we ask every student at the Mount how many hours they work. Well, we're going to take samples over and over and over again. So maybe I'm going to sample 50 students, and I'm going to do it on Monday. And then I'm going to sample another 50 students on Tuesday. And then I'm going to sample another 50 students on Wednesday. And then I'm going to sample another 50 students on Thursday and another 50 students on Friday. And I'm still using good sampling techniques here. So each time I sample, I'm still doing a good, simple, random sample, right? So I'm not just using a convenient sample, but I'm doing it correctly. But I'm doing the sampling over and over and over and over again. Each of those samples has their own mean. So when we repeat this process over and over and over again, we have all the data from all of our samples, and they each have their own mean. So maybe from Monday, the average number of hours worked by students was 20. Maybe on Tuesday, it was 19.5. Maybe on Wednesday, based on the students that I got, it was 24. Maybe on Thursday, it was 15.9. And then maybe on Friday, it was 20.2 hours, right? So every sample is going to have a different mean. They're never going to perfectly match each other because you're getting different people in the sample or different items in the sample. And they're never going to perfectly match the population either, again, because you're not serving everybody. You're always going to be a little bit off. And this is actually a study tip I wanted to put in here. So sample means can vary from one another. It can also vary from the population mean. This type of variation is expected. It's completely normal and usual. And it's called sampling error, which we'll talk more about in chapter 6. So when we collect samples, we know that it's not going to be the exact same answer as the population. And we know that when we sample, even from the same population, I could get different means depending on the people who end up taking the survey, right? So it just depends on who you get, right? It's a random sample. So when we take all these means together from the samples, this creates a new distribution. So the sampling distribution of sample means is when your data points are all the means of the samples. So you've sampled over and over and over and over again, maybe like 50 times or something like that. And now you have all these means, and those means create a new sample or a new distribution. So that's what we're really looking at here. And I think the Venn diagram kind of does a nice job of showing you. So let's say this is your population, and here they took 5 different random samples. So kind of like I was saying, I just surveyed a group on Monday, Tuesday, Wednesday, Thursday, Friday. So each sample is going to have a different mean. It just depends on who you get in your sample. And sometimes they could be equal, sometimes they're not equal. Here you can see you have some overlap, so they're probably pretty close together. But they don't have to be exact. Oh, there we go. So that's what we're looking at in this section when we have samples, usually multiple samples. So the mean of the sample means, and the notation we use here is this one right here, is equal to the population mean. So pretty simple and straightforward. You're just finding that same mean value. But the standard deviation changes. So the standard deviation of the sample means, and again, our data here are all the means. So it's not the original raw data, it's all the means from the samples. So you have mean 1, mean 2, mean 3, mean 4, mean 5. So that's your new data set. Well, the standard deviation of those means is equal to the population standard deviation, but divided by the square root of the sample size. So you have a slightly different formula for your standard deviation here when you have means that you're looking at. The standard deviation of the sampling distribution of the sample means is called the standard error of the mean. So we're going to look more at some examples now, and I think that will help clarify these processes. Or an example, I should say, to start. All right, so here's an example. So the number of times 4 people go grocery shopping in a month is given by the population values 1, 3, 5, and 7. So our population here is very small. It's just 4 people that they surveyed. And one person said they go shopping only once a month. Another person said they go shopping 3 times a month. Someone else said they go shopping 5 times a month. And another person said they go grocery shopping 7 times a month. So those were the answers from those 4 people. A probability histogram for your data is shown on your text on page 262. So I encourage you to check that out there, but we don't really need it here for our work. So you can check it out on your own. And you randomly choose 2 of the 4 people with replacement. So once you choose someone, you put that person kind of back in the hat and they can be chosen again. List all possible samples of size n equals 2 and then calculate the mean of each. Now, there's more there, but I'm going to stop here for a second. So let's just do this first part. List all possible samples of size n is 2 and calculate the mean of each one. So I'm going to make a list of my sample. And then I'm going to make a list next to it and find out what the sample mean is. Now remember, this is our population right here. So those are the only values we're choosing from. So think about it. If I'm randomly choosing 2 people out of here, so I'm choosing 2 numbers. So we're going to list all possible ways that we could choose 2 numbers out of this group. Well, and remember, you're doing it with replacement. So once you choose it, you put it back in the group. So I could pick a number 1 the first time, and then I could also pick a number 1 the second time, right? I could pick a 1 and then put it back in and pick it again. I could pick the number 1 the first time, and then also choose the number 3 the second time. I could pick the number 1 the first time, and then choose the number 5 the second time. Or I could pick the number 1 the first time and choose the number 7 second time. Now, I could also pick the number 3 first, and then 1. I could pick the number 3 first, and then 3 again. I could pick the number 3 first, and then 5. Or I could pick the number 3, and then I could pick 7. Next, I could pick, I'm running out of space here for you guys to see, the number 5 first, and then the number 1. I could pick the number 5 first, and then the number 3. I could pick the number 5 first, and then the number 5 again. Or I could pick 5, and then 7. Finally, I could pick the number 7 first, and the number 1. The number 7 second, and then the number 3. The number 7 first, and the number 5. Or the number 7, and then the number 7 again. So those are all the different ways that I could select 2 people. And notice here, the order, it does matter, right? So we are including both orderings, like 7, 5, and 5, 7, we're counting both of them, right? So think about dragging one person and then picking the second person the next time. So these are all possible samples of size 2. Size 2, because I picked 2 values. So I went through and I literally thought about, okay, what are the different ways that I can pick 2 numbers out of this group of 4? And I list all of them down. So these are all different samples, right? So these would all be theoretical samples that I could get if I just picked 2 people out of the group. And then what you're going to do is you're going to find the mean of your samples. Now, your mean is just your average. So what we're going to do here is I'm going to add these values up and divide by 2. So the first one, I would just do 1 plus 1 divided by 2, which is 1. And then I'm doing 1 plus 3 divided by 2 for the second one. So that's 4 divided by 2, which is 2. 1 plus 5 divided by 2 for the third one, which is 6 divided by 2, which is 3. And then 1 plus 7 divided by 2, which is 8 divided by 2, which is 4. And all the way down the line. So I'll save us the work, but you're going to find the mean for all of these down the line. Okay, and you could use technology here too, but these are pretty fast to do because the numbers are relatively easy and I only have 2 of them. So you can do a lot of them in your head. So the next one here, let's see, we're going to have 3 plus 1 is 4. Divided by 2 is going to be 2. 3 plus 3 is 6. Divided by 2 is going to be 3. 3 plus 5 is 8. Divided by 2 is going to be 4. And then 3 plus 7 is 10, divided by 2 is going to be 5. Just gonna, so I don't lose track of all my numbers here. All right. 5 plus 1 is 6, divided by 2 is 3. Next, I would have 8 divided by 2 is 4. 10 divided by 2 is 5. Here I have 12 divided by 2 is 6. 8 divided by 2 is 4. 7 plus 3 is 10 divided by 2 is 5. 7 plus 6 is 12 divided by 2 is 6. And then 7 plus 7 is 14 divided by 2 is 7. So I find all my possible samples, which is a little bit tedious. So you have to kind of go through and think about every possible combination, and ordering is important here when I'm doing my samples of 2 like this. And then I'm going to find the mean of each of those samples. And now what we're going to do is our means are going to be our new data set. So this is going to be our focus. This is our data set here now. Okay, so we're talking about these sampling distributions. We're taking the data becomes our means or whatever calculation you're doing. So our book is just going to focus on means here, but you could do this for proportions or for standard deviations or really anything else you want to focus on. But means is very common, so we're going to do the means. And what I'm going to do next is I'm just going to go ahead and organize these. So I've done the first part already. I listed all possible samples of size 2, and I calculated the mean of each. So I have all of that data. Now, these means are going to form a sampling distribution of the sample means. And I've told you guys before, when you see that word distribution, just think about a table. So we're just going to create a table here. Excuse me. And then we're going to find the mean, the variance, and the standard deviation of the sample means. So meaning of this new data set. We want to find the mean of this, the standard deviation of this, and the variance of this right here. And then we're going to compare that the actual population results, okay? So first I'm going to do is I'm going to make a table. I'm going to organize all this data. So I'm going to just list my different means, okay? So if I look at all my values here, my lowest value is 1 and my highest value is 7. So I have the numbers 1, 2, 3, 4, 5, 6, 7. And then next I'm going to list the frequency that they occur. So how many 1s do I see, how many 2s, and so on. So I only see 1, 1. All right, so that one's done. Now I do the 2s. I see 1, 2, and that's it. So I have 2 2s. How many 3s do I have? Let's see, I have 1, 2, 3, 3 3s. Now they're not all the same as the number. So for 4s, let's see, I have 1, 2, 3, 4 4s. For 5s, I have 1, 2, 3 5s. For 6s, I have 2 6s. And I'm just crossing them out just to make it easier for me to focus. And then I have 1 7. So this is our standard process when we're doing questions in this section. We're going to write all the possible samples, we're going to find their means, and then the means become your new data set. So now you're organizing the means. So I list all my possible values and I'm counting up the frequencies. Now, the next thing we're going to typically do for a sampling distribution like this is we do also like to find the probabilities. So probability of the x's. So if I count up my frequencies here, I do have 16. So 1 plus 2 plus 3 plus 4 plus 3 plus 2 plus 1 is going to be 16. So we calculate our probabilities the same way that we always have, part to total. So here I have 1 out of 16. Here I have 2 out of 16, 3 out of 16, 4 out of 16, 3 out of 16, 2 out of 16, and 1 out of 16. Now, I'm going to go ahead and leave the fractions here just to stay consistent with your text, but you can simplify these. So you probably want to go through and like simplify your fractions. This one can be simplified to 1/8, for instance, this one to 1/4, this one to 1/8. If you prefer decimals, if the question asks you to use decimal places, they may have you round, which is what we typically do, is like 3 or 4 decimal places. So you can go ahead and convert those over too. I'm going to just leave it like this because this is how your book stops. But again, read your directions in MyMathLab. If they want you to round to a certain number of decimal places, you can go ahead and divide these out. If they want the fraction, I would make sure to simplify your fractions when you can as well. So this is our sampling distribution of the sampling means. It's just the table with all the data organized. All right, we're not done. I'm using different colors here to show the different parts. So we did the beginning part, now we did the distribution, and now we need to find the mean, variance, and standard deviation of the sample means. And those formulas were given on the page before. So the mean of the means, I guess, the mean of the means is going to be the same as the population mean. And the standard deviation is the same as the population standard deviation, but divided by the square root of n. And that's given on the page before. All right, so in our example here, notice that we're told that the population mean is 4, right? So compare results with the mean 4, variance 5, and standard deviation 2.2 of the population. So we know the population mean. So we should be getting then that the mean of the samples is equal to 4. So that's our first answer. Okay, sorry for that pause in the video. I just wanted to bring in some extra work here and kind of have it already done. So what I did here is I used the formula that was given on the page before. So what we should see is that the mean of our data here is equal to 4. And I'm just using that formula that's there. And you don't have to do all this work here, but how can we be sure of it? Like, how do we know this formula actually matches? So what I did off to the side here, when I paused the video for a second, is I actually found the mean of that probability distribution. So go back to your formulas in section 4.1. And remember, we can find the mean of a probability distribution by taking each of the x values and multiplying by the probabilities. And then we add those all up. That's how you can find that mean of a probability distribution back in section 4.1. So I did that here, and you can see the value that I got was actually 4. So it does match that formula they give you in the text here, that you can just use the same answer as the population value. It does actually work. So if you try it out by hand and you use the distribution and you find the mean by hand using that longer formula, it is going to match the shortcut that they gave you on the page before, saying that, well, we can just use the population mean. The shortcut formula for the standard deviation looks like this. So what you take here, I pen back out, is the population standard deviation divided by the square root of n. So if I look up above here, the standard deviation is about 2.2, and the variance is equal to 5 exactly. So remember that if your variance is 5, then the square root of that is your standard deviation, right? So if you actually plug in square root of 5 to your calculator, it's about 2.2. So the variance here that they were using for the population is actually the square root of 5 is the exact answer, which is about 2.2. So moving back down to my formula then, given in the text, I would take that standard deviation, which is the square root of 5, and divide by the square root of n. Now my n here was 2 because my sample size is 2. So you have to go back to that original sample size idea. So I know I have 16 different samples, but that's not my n here. My n is the sample size, and I did samples of size 2. So divided by 2. And if you type this into your calculator, let's see, we get about 1.6. So that should be the standard deviation of the means. Now, again, these are shortcut formulas, so how do you know they actually work? Well, I went back to those probability distribution formulas from chapter 4, so I just wrote them here so you have them. And the one for the variance is I just subtract my x values with the mean. Remember, I square them and then I multiply by the probabilities. So again, I just did that already out, just so you can see how it works. So I took each of my x values, which in this case are mean values, 1, 2, 3, 4, 5 through 7. I subtracted that mean of 4. I squared those values. I multiplied them by the probabilities, and then I added them all up, and what I got was 2.5 here. Remember, this is for the variance. So the variance I got was 2.5. Now, when you take the square root of that 2.5, you get about 1.58, which is about 1.6. So that was the exact answer that I got here, that I got doing it the long way. So what you're having in these two formulas here are really shortcut ways to find these values for the distribution. Okay, so they do work. So if you were to compare them to these formulas right here, you're getting the same exact answers if I go back and use these formulas on our new table. But we're going to save you some time. So you can use these formulas here instead to find the mean of your means and to find the standard deviation of your means as well. So you can kind of jump right to the answer instead of having to do all this work out that we were doing back in chapter 4. Okay, so just a little side note there. So this is probably one of the hardest problems. It's just so many steps. So just to recap, the first thing we did is we found all of our possible samples, and then we found the mean of those values. Then what I did is I reorganized. So I put all my means in a table, right? I put my possible values, I counted up how many I had of each, and I found the frequencies. Once I had all that, I was able to use these shortcut formulas to find out what the mean and the standard deviation would be of this table. That's what we're finding here. We're not looking at this stuff right now anymore. We're looking at the mean and the standard deviation of this table. So those shortcut formulas give you those answers. And they do work. So if I go back, like I said, if I go back to chapter 4 and I do all that work out by hand again for here, then I do get the same answers. Don't feel like you have to exclude all the chapter 4 work though. So these formulas work specifically for normal distributions, like the normal sampling of the mean. So you don't want to apply these formulas to really anything else except for these sampling distributions. So even though I have a shortcut here for this, where we don't have to do all that chapter 4 work, I don't have shortcuts for other chapter 4 problems. So this is very specific to the sampling distributions that we're looking at here in this section.